Hello, my name is Hera Sattar, and I'm going to review the paper published in Nature Climate Change in 2014 named Consistent Increase in High Asia's Runoff Due to Increasing Glacier Melt and Precipitation. This is the outline of my presentation: Introduction, Objective, Study Area, Methodology, and the Results. So, in the introduction, due to the rapidly changing climate, global temperatures are rising at an alarming rate. According to IPCC's fifth assessment report, it's going to be 2 to 5 degrees hotter by the end of this century. This increasing temperature, as well as disturbed rainfall patterns, are also going to affect the river flows around the world. Although this change is going to affect all of us, however, some areas are more susceptible to negative impacts of climate change than the others. So the developed countries like the Northern American countries or the European countries, they are more resilient to the climate change, whereas some other parts of the world like Asia and Africa, they are more vulnerable to the negative impacts of the climate change. So for example, the high mountains of Asia consisting of Himalayas and Karakoram mountain ranges and mainly have glaciers, and the rivers are originating there mostly from the snow-fed rivers, and they depend on snowmelt for their runoff. These rivers in this region originate from the Tibetan Plateau, and a large population depends on their water for their livelihood. But because the region is not very developed, it lacks adequate gauging stations, especially in the upper Indus Basin. Therefore, there is poor quantification of water resources, which leads to lack of understanding of the hydrological regime. The climate projections also contain uncertainties, as different GCMs and different RCMs provide with different estimations. Hence, it is required to estimate water availability in this area with a higher accuracy. These are the objectives of this study. The general objective is to evaluate the impacts of climate change on the water availability in Asia's high mountains. The specific objectives are to analyze the historical and current runoff in the 5 large river basins of Asia, and then to project the future climate in these river basins, and to evaluate the impact of the changing climate on the runoff in these selected river basins. The river basins selected for this study are Indus, Ganges, Brahmaputra, Salween, and Mekong. Only the northern part of these river basins are selected, which are mostly glacier and snow-fed areas. In the methodology, the basin data is used to create cryospheric hydrological model. The basin data comprises of the climate data, precipitation, evapotranspiration, the soil data like infiltration and subsoil data, the ice cover, and the hydrological model is created for 1 by 1 kilometer spatial distribution. The model is then calibrated and validated for 10 years period of 1998 to 2007. Then the data, climate change data from the fifth assessment report, CMIP5 data is used. 4 GCMs are used along with an ensemble of 2 RCPs, RCP 4.5 and RCP 8.5. These RCPs are the future carbon scenarios or carbon emission scenarios. This raw climate data requires bias correction. So therefore, bias correction is done by the delta change approach here, and the future climate is projected from the current year to 2050s. Then this projected climate is incorporated into the calibrated and validated hydrologic model, and the future runoff is estimated. After the future runoff is estimated, the assessment of impact of the climate change on the runoff is done. This slide shows the results, the main results of this study. Here we can see some new names in the river. So Kabul and Satluj are the tributaries of Indus, and Ghagra and Koshi are the tributaries of Ganges river basin. Out of all these 4 river basins, one river basin, which is the Indus, is dependent on the glacier melt, while the others are rainfall runoff dependent rivers. This graph shows the average annual hydrograph for the future period 2041 to 2050 under RCP 4.5 in the major river outlets. And the graph shows the mean projected discharge when forced with the 4 GCM ensemble, and it is showed with the red line, whereas the blue line shows the current and historical discharge. The green portion shows the runoff which is generated by the rainfall, whereas the blue portion shows the runoff which is generated by the snowmelt. So we can see that Indus and its tributaries have a higher percentage of the blue area, which shows that this river is mainly glacier fed, and the discharge is increasing in the future in Kabul and Indus because higher temperatures are more likely to cause more glacier melt in the future. Whereas the other river basins, which are rainfall runoff generated, in there the future hydrology depends upon the precipitation, and the future precipitation increases is causing the increase in the future discharges. If we see the pink colored line, it shows the base flow of the rivers. So the Salween and Mekong basins, which are comparatively closer to the tropical areas, they have more rainfall all over the year. So they have more base flow and more discharge all over the year. Whereas other river basins like Indus, which are semi-arid, there is less rainfall. So there is less less base flow, and there is a higher difference between the dry season and the wet season. Thank you very much. If you have any questions, you can contact me on this email address.